I'm going to talk about linear equations. Linear equations are first-degree polynomial equations with two variables. Here are some examples. 4x minus 5y equals 0. 2x plus 3y equals 4. Y equals 7 minus x. X equals 1015 plus 2y. All right? Now, often people will use x and y for the two variables in a linear equation, but technically you don't have to. So, for example, 3a plus 4b equals 7. That's also a linear equation. Okay, but we'll more often use x and y. All right, so what does it mean to talk about the solution of a linear equation? Okay, let's think about that. So when an equation had just one variable, we were able to isolate that variable and see that the variable was equal to a number. Okay. So what about when we have two variables? Okay, let me go to a new whiteboard and let's focus on x minus y equal to 1. So apparently x and y are equal to values such that their difference is 1. Okay? Can you see that if x was equal to 6 and y was equal to 5, that would work because 6 minus 5 is 1, right? Now, on the other hand, that's not the only possibility, is it? Okay, what about x equal to 4 and y equal to 3? Isn't 4 minus 3 also equal to 1? Or what about 10 and 9? Okay, so we can keep doing this all day, and we can get countless pairs of numbers that have a difference of 1. Okay? Now, in order to express solutions in a more compact way, we use commas and parentheses. So the 6 and the 5, a compact way to express that is 6 comma 5 between parentheses. The second example would be 4 comma 3. And the last example in between parentheses, and then 10 comma 9. Now, notice that the order matters. Okay? If I put them like the 6 comma 5, if I did 5 comma 6, that wouldn't work. Okay? Because 5 minus 6 does not equal 1. Okay? Do you see how the order matters? You can't swap the x and y values. Now, you might in some cases be able to, but in general, you won't be able to. Okay? And how do you check to see that a candidate solution is indeed a real solution? You simply plug in the values. You replace x and y with the values in your pair of numbers. Okay? All right, so now I'm going to find some solutions with respect to the linear equation y equal to 2x plus 1. Okay? I'm going to find the solution with respect to x equal to 3 and x equal to minus 2. So for x equal to 3, I replace x in the original equation with 3, and I see that I get a y equal to 7. So 3 comma 7 between parentheses is the compact way to state that solution. For the minus 2, I get y equal to minus 3. So minus 2 comma minus 3 in parentheses is the compact way to denote that solution. Now, what about if I wanted to specify y values and find the corresponding x values? What about y equal to 9 and y equal to 5? So if y was 9, then I could replace y with 9 in the original equation and isolate x, okay? And you can work that out yourself with pencil and paper, and you'll see that x is equal to 4. So 4 comma 9 in parentheses is that solution expressed in a compact way. And then for the 5, you can work it out in pencil and paper, and you'll see that x is equal to positive 2. So 2 comma 5. Okay, let's end with you working out some solutions for a linear equation. So 3x minus 2y equal to 4. I want you to find the solution with respect to x equal 2, x equal minus 2, y equals 7, and y equals 0. Okay, so pause the video and work that out now, please. Okay, I'll go ahead and work it out too. So substituting 2 for x in the original equation, 2 times 3 is 6, 4 minus 6 minus 2. You could, with a little more work, see that y is equal to 1. Replace x with minus 2. 3 times minus 2 is minus 6. Add 6 to both sides, 10. So y would be minus 5. If y was 7, substituting 7 for y, we would have minus 14. Add 14 to both sides. That would give an 18 on the right side. X would be 6 for that example. Okay, and then for the last example, if y was 0, then you would get a fraction for x, which is perfectly fine. There's no reason why you can't have those in solutions to linear equations. Okay, so putting them all in the compact form, we would have those answers. 2 comma 1, minus 2 comma minus 5, 6 comma 7, and 4/3 comma 0.